size, everything's identical to what...
The only thing that's different, we have got an escape hatch up here.
Okay.
Because we haven't got side opening windows, we put an escape hatch up here, so that will be in the aeroplane. This is the projector for the HUD, so there'll be one. It's an option, either 1 or 2.
Okay.
It's an option. So if you have the second option, it'll be here as well. The HUD is not currently
What's the HGS 6000?
I'm not sure what the... Is it 6000?
Yes,
is it? There you go. Yeah.
Actually, what we did too, the symbology is the same as the PFDs, so there's no difference between the both, so no difference training.
I didn't realize the projectors were that big.
Yeah, we're trying to actually come back to smaller. It'll be slightly smaller.
I think it'll be smaller on that one, yeah. Because on the FTVs, I don't know if you get the opportunity to go on the FTVs today, but if you do, you'll see they're actually smaller. So.
Exactly.
Yeah. Overhead panel, very, very small, which is, you know, because if you're looking up, you know, you're not looking outside. Our whole philosophy was to make massive big windows and to have the pilot looking outside, heads up. So our radio tuning, all our mode control panel, our autopilot selections, they're all on the glare shield there, so the pilot does not have to look down, look away. 5 screens, all big screens. All 5 screens are identical. They're all the same part number, and we can dispatch with 1 screen out. Not one of the primary flight display screens, obviously. So if you're somewhere where you haven't got maintenance or a spare screen, you can just swap the screens over, and you're good to go.
Okay. So control, what are your various input mechanisms? You have the control stick?
Right, we went with the fly-by-wire, so it's control stick, conventional rudder pedals, conventional toe brakes, electric brakes. So we've got electric, the park brake there is just an electric switch instead of the old conventional car type handbrake, if you like. Autopilot, auto throttle, auto brake.
Moving auto throttles.
Moving auto throttles, yep. So that means that they will move with power settings. Which is, you know, I think one of the good things on this program, at least from my personal selfish point of view, is pilots were brought in very early in the program, and the company kept asking us, so what do the pilots want? And we had a few interesting discussions. And so there's 2 of us LIAISON pilots working with the company at the moment. I've come from primarily a Boeing background, and the other gentleman, he's at the Singapore Air Show at the moment, he's come from primarily a Airbus background. So we've got a lot of experience in the world of aviation anyway, and airline flying. We both fly an airline. And so we know what pilots want. And so, you know, talking with pilots in the company, talking with pilots outside the company, talking with customers, we're getting the general consensus of what they're looking for. I mean, you can't do everything for everybody all the time, of course. But this airplane, you know, as probably you're well aware, it's a relatively short takeoff and landing airplane. It's got long legs, so it's going to be E-tops. We'll be able to do steep approaches for the likes of London City. High altitude airports, up to 14,000 foot airports. So it's a, you know,
and
covers a lot of fields.
You've flown one of the test vehicles?
I flew FTV-2 last week. Yes.
How does it compare to the sim?
Simulator is always a simulator. I mean, you've done enough simulator flying to know it's always a little bit artificial, as good as they are. And this hasn't got motion, obviously. But the aeroplane in flight, if you recall last Tuesday, it was a beautiful, clear day. It was just not a breath of wind. And the aeroplane was just so steady. You put it there, it just stayed there. And I was flying in direct mode, and you understand that we're testing in direct mode at the moment. We're testing the normal mode here and in our other devices. So in normal mode it's going to be even more stable.
So you haven't tested in normal mode yet?
In the aeroplane? Yeah. No. So the reason we're doing direct mode is that's our backup. Now we go to direct mode only in the case of a failure. In fact, multiple failures really before we get into a direct mode. So we don't go there very often, but that's our backup mode. So we wanted to make sure that's going to work before we did the test of the normal mode.
And that's different than Airbus. Well, as you know, they have like 6 different modes. Have to train each one. So we decided actually we can have, you know, we have a lot of redundancy. We have multiple failures to get into direct mode, but we really only have to train in 2 modes, which is a big advantage, and that's really what the industry gave us back on the feedback.
So it's primary and direct? Is that what
it's called normal mode.
Normal and direct, yeah.
By the way, this is normal mode. The software in here we're testing for over a month is in normal mode. And it will go on to FTV1 in March.
Okay.
So You've got a manual lever here, just comes inwards and then forwards.
Is that different from typical from cast?
Yeah. It's it just makes it easier because we've got quite a wide cabin or cockpit arrangement here. We've got the space to do that.
So this was one of the trades we did on the program, which was really to make it a good environment for the pilots and the crew. So basically allows better access into the seat.
Yeah, that's nice.
Yeah. It also minimize any risk of damage to the pedestal and gives people a lot of time over it.
Removing the stick does a lot of that for you, right?
Well, it does. Removing the stick allows us to put big screens, and one of the advantages, if you had a control column here, it blocks a lot of your screen. So even though you can still put big screens with a control column, you lose a lot. You block your vision. So looking here now, you got uninterrupted vision. It's huge.
These are the 15.1.
Yes,
and all the same.
The other thing I was able to do too was we got closer to the windscreen for visibility, but also you're closer to the screens because you don't have to have the motion of the control column. So you can actually put the pilot closer to larger screens, so closer to the information.
Now, did you do anything different? Auto flight systems, did you change anything from basic air transport, from the CRJ series or from the...
Well, it's quite a considerable step forward in technology from then. One of the big things we have got is auto land. Every landing, every ILS approach, every landing will result in an auto land unless you disconnect the autopilot, which the pilot does routinely, right? So on final, the pilot disconnects the autopilot and then he'll land. If he does not, then we'll do an auto land.
With what input?
With no input. With no input from the pilot.
Well, what's the tracking?
Oh, it's tracking the ILS.
It's just for an ILS.
Right.
It won't do that for an LPV approach?
No, not this time.
G?
Yeah. G and SS, no.
Is it set up for GBAS approach?
Yes, it is. Yes.
But only for ILS?
Right.
Cat 1, 2, and 3.
3A, 3B.
3A, 3B, yeah.
So 3A is standard, 3B is going to be the option. Option-wise, this is why we're talking about that. We talked about the HUD being an option. The right-hand tiller is an option. And 3B is an option. And that's pretty much the list, at least from a pilot point of view.
Electronic flight bag.
EFBs, yes. Most companies now are just going to go with an iPad. What's that saying? There's an app for everything.
What was the other? Oh, 3B. No, I just saw a press release on a new EFB that you're going to offer as an option. Is that CMC or who was that?
I'm not sure, Rob, are you familiar with that one?
Yes, with CMC.
So where would they put that?
Right there, actually.
Right
when this panel, this is an engineering one, but that panel is removed and there's a docking station that goes right there.
So what more could you want to do that you can't do?
That's a good question.
You can do it all inside the avionics suite, but then you have to, of course, pay the fees to Rockwell. And the other thing is that some airlines want to standardize across their whole fleets, so they'd like to have the same EFB across a single aisle, dual aisle, etc.
Gotcha.
So they just wanted to have the flexibility.
And what you can do with an EFB is you can store all of your manuals. So we're aiming for a paperless cockpit. So if you can electronically store all your manuals, all your reference material, and every company operates a little bit differently how they do it. Factors had a big influence. Real simple things like all the switches in the normal position are in the 12 o'clock position, and they're lined up. A dark cockpit philosophy, that's pretty much industry standard across the board now. So as long as there's no lights on the overhead panel, then you're good to go.
No lights, good to go.
Yeah, and everything is lined up. So we've got auto. Things like hydraulic pumps will be in auto all the time. Anti-ice will be in auto all the time. Even on a day like this, we'll just leave them in auto. And if it detects ice, they will come on automatically. Now you can still, if you want to, you can still manually turn them on or manually turn them off, but just leave them in auto. That's the normal position. Batteries, auto. Everything will be auto the whole time.
So we actually took this panel, it used to be actually 3 times bigger at the beginning of the program, and we got it down to a third by using the philosophy of Mark saying, make it auto, there's only 3 positions. And this was feedback from the airlines as well, really, to try to make it simple and intuitive, and to lower the pilot workload. The other thing too about being closer, some of the older pilots told us that by having the shorter cockpit, you can actually be closer to visually to see the switches.
What do you mean by shorter cockpit?
Because when we took out the control columns, like conventional aircraft, the cockpit got 7 inches shorter.
In terms of how far the seats have to go back?
Yeah, so the pilot relative to the windscreen on this aircraft is between 6-7 inches shorter than other aircraft.
Now, if you've seen the mock-up, you know that the flight deck's it's huge, and the mock-up is the actual size as well. So there's a lot of room behind. There's another jump seat as well. Huge storage cupboards, obviously.
Are there 2 jump seats?
Just one.
Just one. So, in terms of the auto flight modes, it's all the usual. There's nothing new or different about the auto flight mode.
There is one mode that is different. It's this little magic red button here, EDM. We've had this on our business jets for a long time, and the EDM is an acronym that stands for Emergency Descent Mode. What that will do, you can either use it manually, which is why we've got a button, so it's a guarded switch, so we can lift and push the button, or it's always armed, if you like. So what that will do is, if you're at altitude, and if you get a depressurization of the cabin, if the pilots don't do anything about it, the EDM mode will automatically engage. Now obviously we've got a warning at, or a caution rather, at 8,000 feet, we've got a warning at 10,000 foot cabin altitude. If you ignore all that, and the cabin continues to rise, the EDM mode will automatically engage. So it's assuming that the pilots are out of the loop. And you know that there's been incidents in the past. Older technology airplanes, granted, but it has happened, and there's been a couple of airframe losses because of it.
Yeah, both in business and in commercial aviation.
And so what does it do? What's the...
Okay, so what it's going to do, it's going to do lots of things. It's probably probably the only time where this airplane actually takes control, because it assumes the pilots are out of the loop. It's going to automatically engage the autopilot if it's not automatically engaged. Normally it will be engaged already, right?
Okay.
In cruise. It's going to automatically engage the auto throttle. It's going to pre-select the altitude window to 15,000 feet. It's going to engage, it's going to squawk 7700 on the transponder, the emergency code. It's going to close the thrust levers to idle, and it's going to pitch the nose of the aircraft over, and it's going to descend at VMO, or MMO, VMO, down to 15,000 feet, and level off, and maintain the current heading and 15,000 feet. At 15,000 feet, the pilots will come back to the seats, just wondering what's going on, and take control.
So no TOLS protection?
No, there is, yeah. It's a good question, and it's an obvious one everybody asks, but no, there's not.
If you happen to be flying in the Himalayas?
It's not your day, really. If you happen to be flying in the Himalayas, and you have it, yeah.
Right.
There's not too many places in the world where it's going to be an issue.
And so in terms of envelope protection for the pilots, is it auto throttle?
Auto throttle.
Do you have speed protection,
yes, we
high
do.
and low all
Yeah.
the time?
Yes,
Can't
we
get
do.
out of it? Not like a Boeing?
No.
Or an Airbus?
No. So you are overspeed protected, underspeed protected, yes.
All the time?
With flight envelope, correct. When you're in normal mode. Now the only difference, or the primary difference from a pilot point of view between normal mode and direct mode is envelope protection.
No envelope protection in direct mode?
That's correct. You still got stick shaker.
Oh, you have some, just less, limited.
What's left?
Well, you've got low speed warnings, but not protection as such.
Right.
And what are your warnings?
Stick shaker. And you'll have a speed call, low speed
Oral
calls.
and stick shaker.
Yeah. But what we can do is we can climb up, we get airborne, we're in normal mode, and we'll just have a look at these protections. So
Yes.
it's probably easier to demonstrate it rather than talk about it, if you like.
Okay, so it's recording. Perfect.
Yeah, it's flashing light.
One
Okay.
of the things, the difference is compared to the Airbus philosophy, which is attitude stable, the control laws. Ours is speed stable. So it actually controls the energy of the aircraft. You'll see the trim switch on the top of the stick, which Mark will explain to you.
Just a conventional trim switch.
Yep, and that's a really key point of the aircraft once in the flight deck. you basically can use that to pick your speeds, and the aircraft will automatically trim to that speed. And Mark will explain that as we fly. And it controls the energy. It's much more intuitive and flies much more like a conventional aircraft. And that was the concept, really, from the group.
I think
so. So an Airbus you trim to a certain altitude. Here you're trimming to an airspeed.
Right. Right. So it's a speed stable platform.
And that's through the fly-by-wire system.
Right. Well, you make the fly-by-wire do anything, can't you? Right. But that's the way we've gone with that fly-by-wire.
Is there a technical name for speed stable versus attitude stable?
Just not that I'm aware of.
And did you pick that based on
what pilots want?
That's it.
From the feedback from our clients.
Yeah,
it's the way that a conventional airplane, doesn't matter what it is, even a little single engine, it's the way airplanes fly.
Set your trim, gives you a certain airspeed.
Right.
Pack equals performance.
Yeah. There you go. Go way back to your basic aerodynamics. It's the simple way pilots learn to fly. All the way through, we've tried to make it as pilot intuitive as possible. And that way, we're trying to reduce the training footprint as much as possible. Now, by regulation, we still have to spend a certain amount of time training pilots for a type rating. But what it does mean is, instead of teaching them about systems that should be intuitive, we can concentrate more on what they really need to concentrate on, flying the airplane safely, as opposed to learning individual systems and how hydraulics work and that type of thing.
Okay. That's a good segue.
That's a good way to see where we go flying, right? Okay, so we've got the forward aft there. The rudder pedals, are you pretty comfortable there?
Yes, that's good.
Side sticks. So the side sticks are individual. Okay, so they're not interconnected. The thrust levers with the auto throttle on will be interconnected, so they're back driven. But the auto throttle is not connected in the eSIM at present.
Okay. What's not connected in the eSIM?
The auto throttle is currently not connected. Autopilot is, but auto throttle is not.
All right.
So what I suggest we do, we just get airborne, we climb up, we'll look at the speed stability, we'll just look at the envelope protection, and it's probably easier to demonstrate it rather than talk about it, and we'll talk your way through at the same time.
Let's do it.
Okay. So, electric switch for the electric brakes, so it's just a switch, on or off. Okay. Let's set some flaps, we'll go to flaps 4 for takeoff.
Which is how many degrees?
I don't know, and I don't really, to be honest, I'm not being flippant, but I don't care. From a pilot point of view, I don't need to know how many degrees that is. I just need to know that it's a flat 4 position.
So John, we have 5 flight positions. We have them set for entering flight test program. And we're actually, we'll start next week doing the stalls and determining which angles are optimized. The first ones are actually set at 7 degrees, but there's the 3 takeoffs and 2 landings.
And so this is like an example, like on the RJ, which you're familiar with, we have degrees of flaps, right? And so you say, give me 8 degrees, give me 20 degrees.
This is more intuitive.
Just give me flaps 1, flaps 2. Okay? Flaps 3, flaps 4, 5. So
why 5 levels? Did you need that many levels?
Well, what we did was we wanted to optimize the performance, because it's as Mark mentioned before, we have London City where we have certain takeoff performance that we want to be able to do, but also we have hot and high conditions that we want, and then more regular. So we decided to go with 5 positions, so 2 landing and 3 takeoff.
But in general, I guess an operation would use probably 2, 1 for takeoff, 1 for landing.
Probably a normal landing will be flap 4.
Yeah.
Flap 4 landing, and flap 5 will be for the shorter fields.
What about takeoff?
Typically 2 for takeoff,
yeah.
1 for landing.
Yeah.
Okay.
All right.
And how do you activate the slats?
Well, the slat flap. So here we have the slats on the leading edge.
All right.
Okay. And if I go back to 0, so they're in movement now. So the flaps are moving, slats are not. Okay. So the flaps will come to 0. And now our slats will start moving.
Yeah, slats always go out first and come in last.
That's it. Okay.
So they're automatically off.
Yeah. So it's just one lever controls both. And I can pull up a synoptic page on here.
Spoilers here.
Right. Lower synoptic. Let's come to our flight control page. And so here's our flight controls here. So flap 0, which is there. Now if I go to position 1, my leading edge will come out, you see.
Do you have pictures of all this?
Yeah.
We got a nice
brochure. Yeah.
Okay.
Okay. And then see our flaps coming out, and our flaps will start deploying here.
That's the advantage of the big screens. You really visually see what's going on with the aircraft.
That's it. It turns green, so that's flaps 2.
The gear will show up where?
Right. The gear is gears here. 3 pins.
Okay.
All right.
Did you explain the screens can be full or split as well?
Right. I can. So at the moment we have I have the map on here. I've got the status page or synoptic page here. We've got a systems page down here, FMS. What I can do, if I put the same on here, so if I come across to my upper screen, and we have a trackball, just like a mouse on a computer. Okay. We looked at using touch screens, but there's problems with touch screens. This is far more accurate. Also, with a trackball like this, it highlights the field before I activate something. So you can see it highlights the field so I know before I activate, push the button on the side, just like a mouse. Before I activate, I know that's the correct field. Now on here it's not too bad, but when you start getting into smaller menus, like smaller boxes, if I go to here, symbols, see there's lots of them. So it highlights the field before I activate something. Now if, on your iPad or your iPhone, often you're pushing the wrong one, aren't you?
That's very nice. This is part of the Fusion, Fusion, is that?
Yes.
Fusion, yeah. ProMind Fusion. The other thing maybe, last point I want to let you guys fly, is we made, we're the first industry to not have cascading menus. So you see the tabs with the large screens allows us to have these tabs, so there's nothing cascading. Everything is visual to you, so you don't have to go look for everything. It's right in front of you.
And then just to answer the question on full screen, so if I put the same information on both sides, then I can have a full screen map.
Okay.
Now if we lose the screen, just while we're talking about that, the information, so if I lose my primary flight display, the information will automatically revert to here. Okay? So the philosophy is going to come inwards and downwards. Okay?
Yes.
Let's go fly. So park brake is off. We've got our flaps 4. There we go.
Anything different on the engine?
No.
Information based?
No, not really. We're N1 based information, but no, there's nothing really startlingly different there. We have, I'll just bring it around the corner here for a stop and I'll demonstrate. So with the shading, so at the moment if I bring it to a halt there, so if you can see that there's it tells me what I've set. So I can set the thrust to there, for example, while the engine's spooled up, you see.
Based on the FMS?
Right, and then you see, so it gives us a prediction of where I'm going to have it set. So it gives the pilot a really nice intuitive little idea as well. So we have that, and we have on the airspeed, which is the same as what we've got on the RJ and the business jets, we've got a prediction of the airspeed and the altitudes on our rate of acceleration. So as I accelerate for takeoff here, if I bring I'll just bring the thrust up, and we'll start rolling here. So you can see as we come through 30 knots, the airspeed becomes low. Actually, it's not functioning on here at the moment. There's 80 knots we've got on both sides. And there's our V1. Okay, now if I just let the stick go, it's trimmed for this speed. So you see the speed slowly coming back? and it's going to stabilise at that speed.
Which speed will the
So
where it is?
where we're trimmed, where the cursor is set there now.
How did you set that speed?
That's just I've set it up here, a manual speed. Now if I lift the gear up, okay, the aeroplane should accelerate, shouldn't it?
Yes.
But it won't, because it's speed stable. All it will do is it will climb at a greater rate, because we've trimmed for a speed. Okay, now if I want to bring my speed up, I don't touch the power, I'm just re-trimming. So let's trim it for 160. So it pitches the nose down, it's going to find our speed, and now if you look outside, it's going to pitch the nose up again and maintain that speed. I'd overshot by 5 knots, but it's going to settle down a bit. Now if I bring my thrust back, so at the moment we're climbing at about almost 4,000 feet per minute. So I bring my thrust back.
And this is with the autopilot off, obviously.
This is autopilot, yeah, this is exactly. No auto throttle, no autopilot. Exactly. It's speed stable. So I bring my thrust back. The speed did drop back a little bit, but now it's going to start accelerating again, but it's still going to maintain that same speed. So that's our speed stability. Okay?
Okay.
Makes sense? Now I'm going to start...
You let the vertical speed be the variable.
Yes, yes. If you like, yeah, that's one way of describing it. Now with the other thing, on our symbology here, we've got slap misconfigure. So we just had a momentary caution message there, a slap misconfig, but it's come back again now, so life's good. It's going to start accelerating here a little bit. The other, we have got, so these white symbols are our conventional pitch of a conventional aeroplane. Okay, so currently we've got a nose up of about, let's say 5 degrees, right? A little bit over 5 degrees, maybe 6 or 7 degrees. But see the green symbol right in the middle there?
Yeah.
That's our flight path vector.
Okay.
That's where the aircraft is going. And where the aircraft's pointing and where the aircraft's going is not necessarily the same thing.
It's even more useful for synthetic vision. Is that
Right,
the way for
right.
this?
And this we can put synthetic
is
vision.
that an option?
It's not an option yet, but it's the future. It's a future development.
Capable though.
It is, exactly, it is capable.
It will be an option in the future.
Yes. Both EBS and SBS. Maybe John, let Mark have a go, no?
Yeah. John. So, let's get the flaps coming up here. So, see how the speed is in amber at the moment? That's because our predictive speed was in the, was saying we were going to do an overspeed, but the flaps are coming up now. So if you put the green symbol on the horizon, you just split the horizon perfectly with that green symbol, as you are there, okay, you will stay straight and level, because the aeroplane is indicating straight and level. So you, at the moment, your nose up maybe 4 or 5 degrees.
This power's fairly low, I guess.
Yeah.
What's the green?
The green is our pitch limit. Okay. So we'll talk about angle of bank first. So if you just roll it right or left, either way. Okay. Now let go. It's going to stay there. Okay. It's going to stay at what you got there, 18 degrees angle of bank. It'll stay there all day, around and round and round.
What is so?
Okay.
It's still flying the speed.
It's still speed stable. Exactly.
So it's going to let the VSI run.
Exactly. Exactly. And I can control that a little bit with the power, but so when the auto throttle is connected, that's all going to be so straightforward. Now, if I want you to increase the angle of bank beyond 30 degrees, roll it over, more. There you go. Now let it go. Okay, 45 degrees. Now it's going to come back to 30. So that's our normal mode fly-by-wire protection.
Maybe explain why 30.
Well, 30's a
Conventional.
rate 1, yeah.
So anything over what takes you back to 30?
It'll bring back to 30.
Anything
yes.
over 30?
Yes. Yeah. We can roll it to approximately 80 degrees, which is a lot. Passengers don't like that, but if you had to, you can.
Some.
So, yeah, exactly. Now, the other thing that we're a little bit different with our control stick. Let's bring it back to straight and level here. So that's the roll. Okay, so up to 30, let it go. It's going to stay there all day. Beyond 30, it's going to come back to 30. Okay, but you can't go beyond 80.
You're going to say why you picked 30? I missed that.
Yeah, so that's the kind of the classic commercial aircraft banking angle when you do a maneuver. And so it's anything 30 or less to be correct.
Okay.
And so if you put it at 15 or 20, it just stays there. So it's to reduce the pilot workload.
Okay.
But more than 30 is unusual. That's why it comes back.
Okay.
30 is probably a good round number that most pilots
It's probably about standard rate turn.
Yeah.
Yes, you got it. Yeah.
Now, in pitch, so in roll, we're happy with that.
Yeah.
In pitch, we can pitch up to 30 degrees nose up, which is a lot, and 20 degrees nose down. So if I push the stick forward, just push it all the way forward. Okay, there's 20 degrees. It's not going to let me go beyond that. Now if I keep holding it there, the nose is automatically coming up. See, it's holding it. It's over speeding, but the nose is coming up, and the speed will start washing off again. So even though I've got full nose down, I'm limiting my pitch to 20 degrees nose down. Now that's pretty dramatic. You would never normally go to that. But just take my hands off, not doing anything now, it's going to come back to our speed that we were trimmed at before.
Got it.
Okay. Now when I did that, we have a normal range of motion of the stick, forward and aft, pitch mode. If for some reason you need to exceed that normal force or G-force on the aeroplane, for terrain, for traffic, for whatever reason, you can on this aeroplane. Okay, so you can exceed the normal G limit of the aeroplane. Okay, but just get hold of the stick there, pull it back, all the way back, hard back, right back. Now pull harder. So did you feel there's a resistance there?
Yeah.
And then so we call that the soft stop, then the hard stop. So if you go to hard stop, you will exceed the normal G limit of the aeroplane. It will require an inspection on the ground, but you did it for a good reason, and you're not going to do it inadvertently because of that resistance that's there, right?
And this is the philosophy between Boeing and Airbus, which we debated heavily. The Airbus one is you don't exceed ever the limit of the aircraft. The computer, the aircraft takes the priority over the pilot in that case. The Boeing philosophy has been, the pilot has full authority to take the aircraft to absolute structural limits. So it's really in the pilot's hands. So we actually combine both. For normal operation, soft stop, the aircraft will keep you within the design limits of the aircraft, no inspection required. But if for, let's say, a very exceptional event, to avoid another aircraft terrain, you can actually exceed the normal limits, give the pilot every chance of missing or surviving the incident, and then there's structural inspection required.
Okay. So on the display for pitch down and pitch up,
Right.
you revert to the arrows.
Right.
That's
That's for unusual latitudes. That's right. Yeah. Exactly.
You don't do any changes of the display
No.
itself.
No.
Okay. Are the ladders always fixed at these levels, or do you change
Yeah.
anything?
No, it's fixed to that. Yeah.
All right.
All right.
I did feel the shaker.
Yep. Yep.
Is one level of shake or is it change?
No, it's one level.
And how much ahead of the stall is that?
Well, we're actually working on that. We're still changing that from time to time. We're looking at that and seeing which is the best for displays to coordinate it with our low-speed queue. So it's not fixed yet. It's not a fixed number yet.
Yeah, we'll do that after the stall test.
Okay.
So yeah, and we haven't done the stall testing on the airplanes yet. So we're still, early in the game, if you like. I'm just going to head back around the left here, so not too far away from the airport.
Okay.
Okay, so if I wanted to, if I roll it all the way hard left,
Bank angle
it warns me.
Bank angle.
Okay, and now if I just let go,
Bank
it's going to come back to 30,
Bank angle.
and it's going to re-establish that speed we're at. It's speed
But
stability.
you could hold it in.
I could hold it
as long
in,
as you wanted?
as long as I wanted, yeah.
How
So I
come
want
you
to
didn't
ski the
put a
test
limit
years.
there?
Well, because our philosophy is that the pilot, at least the pilot's philosophy is, the pilot always has control. Okay? So if you need to do that, if you need to go to 80 degrees, you need to for good reason. Now, you know, we could have had absolutely no protection at all and let the guy do barrel rolls if he really wanted to on a bad day, or we could limit him a lot more to say, what would you say, 45, 60 degrees, something like that. But you know, if a pilot wants to avoid something, he wants to avoid it. So why limit him, you see?
So there's no limit at all?
80 degrees.
80 degrees?
80 degrees,
Oh, I
yeah,
didn't-
yeah.
What happens if you get to 80? What's it do?
It just won't let you go
It won't?
anymore.
Okay.
Let's try. Let's try. Okay. So there's
Bank angle.
there's 60.
Bank angle.
There's 80 there. I'm just holding it,
Bank
and it's just going to keep on coming around.
Bank angle.
No,
Bank
I
angle.
can't hold it anymore. So I'm holding it there, and it's just not allowing me to go more than that.
Bank angle. Bank angle.
By the way, you're testing the normal
Overspeed.
mode, just to let you know.
Overspeed.
Yeah, that's right.
Overspeed.
All right.
All right, let's bring this.
Now what's the magenta symbol that's a little bit cocked off? Is that a...
Okay, that's our, yeah, so the magenta in this aeroplane is information from the aeroplane. Okay, so if we look around the flight deck here, we've got magenta down here, FMS, we've got magenta here, which is power settings, magenta, needles. So anything that's magenta is information being given to us from the aeroplane.
Oh, I see.
Okay,
Of course not.
so basically it's a flight director. Okay, so if I want to go to 5,000 feet on our current heading, so I've got heading mode selected up here. Let's go flight level change. All I do is put the green symbol over the magenta symbol. Let's just come back around where we were. And that's what the, it's just like a flight director, that's all.
Okay, good.
Okay. And we made that symbol deliberately. We put longer wings on that symbol so that we could see it when we're superimposed, which we would do all the time, like that. So we can still see that symbol. And our flight path vector, we put a little tail on it so we can tell the vertical.
Now you're not doing anything with the HUD yet?
No, not yet.
That'll be when?
It's functional on the aircraft.
Yeah, probably it's not a high priority right now with other higher priorities, but it'll be coming very shortly.
Yeah, you can
The
see-
HUD will be the same symbology as our PFDs. Okay, so traditionally, with different symbologies in the HUD than the PFD, it takes a while for the pilot to transition from one to the other. Doesn't matter how experienced and how qualified he is. So by having the same symbology, that means there's no transition time required for him to readjust his eyes or readjust his thinking. I keep going away from the airport. Sorry, carry on.
You're seeing a split between airlines whether they want to do their Cat-3 landings with the HUD or with the auto land system?
Currently there's no advantage for the airline from a pure murmur point of view for landing. Okay, but from a situational awareness point of view for the pilots, it's huge.
Yeah.
It's huge. So instead of us looking down, like both of us now are looking down, aren't we? Instead of that, if we're looking outside,
Can you put it up?
then outside's where the action is. And especially when you're landing on a bad day, when you're coming in, and we'll have the same thing, we'll have a flight path vector, and if you've got the flight path vector on the HUD, coming in to land on the airport, if you put that flight path vector on the threshold of the runway, that's exactly where the airplane's aiming.
So some customers may get the, instead of getting the 3B, they'll get the HUD.
Right, right,
Lufthansa,
right.
City Line.
Yeah, they're a big believer in the HUD. Yeah.
I'm just going to put the HUD up for you for a second. You'll
I'm
be
not-
able to see.
yeah.
Show you the HUD for a second.
Okay, I'm not sure if
Put
it's
it down. You'll be
calibrated
able-
correctly.
We'll just put it out.
I think
The beauty of
it's,
this thing is you don't have to wear glasses.
that's right. It's
That's good, eh?
yeah.
feel young again.
It focuses to infinity like that. I'm not sure what that means, but I've heard that phrase.
That's very nice. The same exact,
Yeah.
Working out? Yeah. Okay, good.
I think it's made a slight curve on the horizon at the moment. Is that correct? No, is it good? Is it? Okay, I haven't used it for a while. The last time I used it, it wasn't.
It's seamless.
Good.
Cool, eh?
Is synthetic vision on the HUD will that be an option as well?
I don't think synthetic vision will be on the HUD, no. I don't think it's not a...
Because it is on the Global 7.
Not on the HUD, is it?
The Globals, yeah.
Is it?
That's what the
Oh, it is
strap
too.
was
Yeah, it is
saying.
too. Yeah. So you're right. Yeah.
So,
So I guess so in the future.
we're going to have it on the displays and later on the HUD. And in terms of airline picks, Europeans tend to prefer the HUD.
For what, sorry?
The European customers are much more favorable to selecting the HUD.
Handling all this information we have here. So we have quick access keys. You've got 6 quick access keys here. I've got 6 here. Okay, and then down here we have the same 6 keys. And so these quick access keys, there's 2 ways we can pull information up. Either I can pull up my cursor, I can go menu, and I can select, let's say, FMS. Okay.
How do you do that?
So yeah, go menu, which is the button on the front here. Push that, and now you can scroll down to whatever you want.
Gotcha.
Okay, so you can do that.
Can you show me FMS on the phase-by-phase?
No, I have not. No, I have not. We'll do that.
Great.
So that's one way of doing it. Okay. Another way of doing it.
How do you go back real quick? I wanna
Okay.
go back
Well, back to what?
to the previous screen.
No, there's not a option to do that as such. But what I would do is just use. So we had map up, right? Just push map. Okay. So that's one way of doing it through the cursor. But an easy way is just pushing these buttons up here, and you can pull up these. That's a data page, CNS, data link, FMS. So we can do that.
Was this a collaborative between Bombardier and Rockwell Collins?
Yes.
This
Yes.
idea?
Yeah.
Is do the Globals have this, or this is new for the CSeries?
This is new for C-Series.
What used to be up there? What is typical?
Standby radio, standby...
Well, remember, this is a complete clean sheet of airplane.
yeah.
So, you know, it's like a question. What used to be here? Nothing. You know, if you like. So quick access keys up here, radios up here, all our modes, flight modes, autopilot, all up here. So our philosophy is we don't want guys down here tuning. We want guys up, looking up.
Which goes well with Rockwell Collins'
Right.
philosophy. Okay.
Now the other thing with our FMS, this FMS is a total redesign. It's been designed by our pilots in-house, and it's a phase of flight FMS. It's very, very simple to use. So if I'll use your one because you've got it up already. So our phase of, so this is our database. Okay, position. So on our position pages we've got a tab under position, so FMS position, IRS positions, okay, GNSS position, VOR DME position, so you can deactivate or activate. I won't go to every page in detail, we'll be here all day. Flight plan page, we can download, we can type in a company route, we can uplink a flight plan from the company. At the moment we've just got Toronto in here. We can enter data, we can enter departures, we can enter arrivals. So it's very, very easy, very intuitive. Okay. Performance page. Again, we've got different windows. So performance, we've got departure performance, our V speeds, our climb performance, cruise, descent, and our arrival phase of flight. So we've coined this is our phase of flight FMS. And then finally we've got our route page, and then our route legs, position reporting. So you're doing a position report, it's all there. Your flight log after flight tells you your times and everything like that. Again, we won't go into a whole lot of detail, but so we've got the phases of flight across the top here, and below here we've got the information you need for that flight. Okay. Now we also will have an ECL, which Rockwell Collins are currently putting together for us. The electronic checklist follows the same basic format It's interactive with the aeroplane. It's sensing. So if the checklist tells you to put the gear down, for example, and we put the gear down, it'll tick the box. The gear is down. So it's interconnected to the aeroplane systems.
To the first single-aisle aircraft with a proper check see an electronic checklist.
The first thing what?
First single-aisle aircraft with an electronic checklist.
Will that be on the initial
Yes.
deliveries?
Yes. Yes. Again, paperless. So we don't want pilots carrying paper in the flight deck. All due respect to a journalist, but but you know what I'm saying, right? So it should be it's all electronic. So the normal checks will be in the electronic checklist, and the non-normals will be there as well. All your non-normal events.
Normals and non-normals.
Non-normals and non-normals. Yes.
Okay.
Now, I don't know if you noticed, but just as we're talking here, I have been paying much attention to the aeroplane, but we're still at the same speed, and we've been slowly climbing because I had a little bit too much power on, okay, because the auto throttle's not connected. So if I just bring the power back a little bit now, it's going to maintain the same speed, but it's going to be descend. So we're speed stable. Okay, now under the old traditional pitch stable, we would have slowly gone down and down and down and down. At the ground, maybe. That has happened.
Okay.